Okay, I'm going to do question number 3 from the estimation problem set. So this question reads, a dermatologist investigating a certain type of skin cancer induced cancer in 9 rats and then treated them with a new experimental drug. So as I read these problems set questions, I always write down vital information. So our sample size is 9. For each rat, she recorded the number of hours until remission of the cancer. The rats had a mean remission time of 400 hours. And a standard deviation of 30 hours. Because these rats are our sample, we're going to be using our estimators, x bar and s, rather than using our parameters, mu and sigma. And then it wants us to calculate the 95% confidence interval for the mean and variance using this data. And what assumption must we make? We must assume that x is distributed normally. And because our sample size is 9, which is less than 30, we cannot use the central limit theorem. So our underlying distribution has to be distributed normally for us to be able to proceed. So the formula for the 95% confidence interval about the mean is as follows. And because we do not know the variance of the population, we need to use our t distribution. So t, degrees of freedom, is 9 minus 1, so 8 degrees of freedom, and 1 minus alpha divided by 2 gives us 0.975 because our alpha is 0.05. So we will go to the t table, and 8 degrees of freedom, 0.975, gives us a t-score of 2.306. And that is what we plug into here. So if we sub in our values now, 400 plus or minus our standard deviation divided by square root of our n times 2.306, and that's going to give us our lower limit of 376.94 and our upper limit of 423.06. So that is our 95% confidence interval about the mean. Next, we want to do our 95% confidence interval about the variance. And our formula for that is as follows. I will move my hand in a minute. So for this, we use our chi-square distribution. And on the lower limit, we do chi-squared degrees of freedom, again, is 8. And 1 minus alpha over 2 is 0.975 for our lower limit side of the formula. And for our upper, it's again 8 degrees of freedom, but it's just alpha over 2, which is 0.025. So we will go to our chi-squared table. And 0.975, 8 degrees of freedom, 17.53. And then 0.025, 8 degrees of freedom, 2.18. And then we'll plug in our values again. So and that gives us our confidence interval around the variance. And that is that for that question.